Welcome back to another edition of segments, but this time we are going to work with midpoints instead of segment addition. So a midpoint basically means the halfway point. What it does is it cuts a segment in half. So let's pretend you have two segments of equal length. We have a segment that is 5, and we have another segment that is 5. What you can imagine is if you put those two together, it's going to make one large segment that is 10 units long. Think about it any way you want. I mean, if you are a football player and you're doing 100-yard sprints from one end zone to the other, and once you get to the 50-yard line, you are halfway there. If you are taking a 14-mile road trip and you have driven 7 miles, you have 7 miles left. You're at the halfway point. If you are running cross country and you're on a 3-mile race, once you get to 1.5 miles, you are at the halfway point and you have 1.5 miles to go. A midpoint is right in the middle. So it cuts a segment in half, which makes solving these equations a little bit easier, but there are multiple options. Here's the deal. This piece, A, is the same as this piece, B, so you can just put them together and set the left side equal to the right side. You cannot do that with segment addition. This can only be done with midpoint problems. The other one is we know that if this is a midpoint, this is A, this is also A. I mean, they're the same length. So if this is 5, that's 5. So we could also just multiply 2 times a little piece and set that equal to the big piece. So there are 2 different equations you can use to set up a midpoint problem. So we can set the little equal to the little, or we can do 2 times the little and set it equal to the big. Okay, so there's 2 different equations. So let's look at the first example. It says B is the midpoint of AC. We know that AB is 6 units long. So since B is a midpoint, we could answer the rest of this just by saying, well, if this little piece is 6, then this little piece is 6, and 6 plus 6 is 12. So BC is 6, and AC is 12. Look. The left and right pieces are the exact same because B is a midpoint. B is halfway from A to C. You walk 6 miles, you get to the halfway point, you walk 6 more, and you're tired because you just walked 12 miles. Okay? Number 2, very similar. You are on an 18-mile road trip. Not that I'd consider 18 miles a road trip, more like just a drive to work, but still, 18 is the total distance. You stop for coffee halfway there. How many miles is it from D to E and then E to work? So all you have to do is split 18 in half and get 9 and 9. Okay? So that's midpoint. So let's do a couple of examples algebraically. We'll start with number 3 and 4. I'll step you through one, you step through another. Notice we're looking for AB. Now, that means we're going to have to find x first, so we need our equation. AM is a little piece, 2x plus 3. MB is a little piece, 5x minus 6. So remember, there's 2 different ways to set these up depending on what we have. We have 2 little pieces, so that means we're just going to do little piece is equal to the other little piece. We're just going to solve. And we get x equals 3. We are looking for the length of AB. So we are looking from here all the way to here. All you really need to do is plug it into one side. But if you want to be cautious and make sure you're doing the problems correctly, you will plug it into both sides. Reason why, you can check. If the left side is equal to 7 and the right side is equal to 12, you did something incorrect algebraically, since this is a midpoint problem and the left should be equal to the right. So let's plug 3 in. So we have 2 times 3 plus 3. So 6 plus 3 is 9. AM is 9. If we did this correctly, the right side should also equal 9. So we have 5 times 3, which is 15, minus 6, which is 9. So we know the length of AB is 18 units long. All right? So number 4, I'm going to let you pause and try this one on your own from start to finish. See if you can get an E. Give it a shot. If you got NE is equal to 26, you are good to go. Now, first thing you had to do was look, and here's a little piece, here's a big piece. So you had 2 options for this one. You could just write that NE is also 3x plus 2 because remember, with midpoints, the left side is equal to the right side. That also means expression-wise. And then you could just do little piece plus little piece equals big piece. Or you can remember, if you have a little piece and a big piece for midpoint, 2 times the little piece is equal to the big piece. So either one of these 2 equations will work because once you simplify the left side, it's going to give you 6x plus 4 no matter how you look at it. Set it equal to the big piece, you get x equals 8. Plug 8 back in to the x in the NE segment. 3 times 8 plus 2 is 26, and you're good to go. So that's that. One more example we'll step through together. This is a double midpoint problem. So we know that C is the midpoint of AD. So this is the halfway point for the big segment. But then we also know that B is the midpoint of AC. So that means B is the halfway point from A to C. And what we're going to do is come up with an equation that'll tell us how far it is from B to D, but we need to use 2 midpoints to find x. So let's start with the little one. We have x plus 2 for AB, which means BC is also x plus 2. Which means from A to C, we know is 2x plus 4, which means from C to D, since C is the midpoint, is also 2x plus 4. So then, all we have to do is 4x plus 8 is equal to 5x minus 2. That's the 2 little pieces adding up to the big piece. Solve, and we get x equals 10. So to find BD, we just need to substitute it in. So from B to D, we have 10 plus 2 is 12, and 20 plus 4 is 24. So the distance from B to D is 36 units. So that's a double midpoint problem. So again, that completes our lesson for midpoint. There is another challenge problem if you are interested in practicing systems of equations. Again, I'm not going to step through this one. We will save this for class. If you would like, you can look at the answer key to the notes if you want to check at home. But that's it. This is another example of solving a system of equations with midpoint problems. Okay, this is Longo and I'm out. See you, bye.